per second.
Seems to have passed this very critical point of peak heating and peak deceleration. The next big step is parachute inflation.
And you can see that on our timeline on the bottom of the screen. The next event is parachute deploy.
InSight is now traveling at 1,000 meters per second.
Very close.
Once InSight slows to about 400 meters per second, it will deploy its 12-meter diameter supersonic parachute. The parachute will deploy nominally at about Mach 1.7. Standing by for parachute deploy.
Radio science reports sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo, maintain lock status.
Telemetry shows parachute deployment. Radar powered on. Heat shield separation commanded.
This is really good news so far.
It's fantastic.
I'm on pins and needles.
We have radar activation where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer above the surface, the lander will separate from the backshell and begin terminal descent using its 12 descent engines. Altitude convergence, the radar has locked on the ground.
Yes.
Standing by for lander separation.
Carrier interruption on Marco Alpha and Marco Bravo.
Lander separation commanded. Altitude 600 meters. Gravity turn, altitude 400 meters.
We're getting there.
300 meters. 200 meters. 80 meters. 60 meters. 50 meters, constant velocity. 37 meters. 30 meters. 20 meters. 17 meters, standing by for touchdown. Touchdown confirmed.
That's fantastic.
This never gets old.
No, it doesn't, Rob. Control
what a
room
relief.
just erupted.
Fabulous,
Hands
fabulous.
with the Marco team
Marcos.
there.
Marcos team, you did great. Tim Preiser, one of the key designers at Lockheed. Sandy Krasner, what a great
relief.
team. What a great. This is really fabulous.
Fantastic news.
Thank you.
Lots of fist bumping going on in there. What a relief. We've cut over to the camera over in Times Square. Boy, people are weathering the rain to see this.
They can't help. This is the hardest part. Getting to the surface of Mars is very hard. This thing has a lot more to do, though. There's a lot more to go on both today and the days that follow before the science can begin. But just getting a vehicle from Earth to the surface of Mars is no mean feat.
And Rob, could you talk about that? I mean, just the mere accomplishment here that we're seeing.
You have to understand that this vehicle is very complicated. It uses 12 engines. Each of those engines are pulsed 10 times a second, producing these little tiny impulses, almost like little bullets that keep the vehicle going at a constant velocity as it approaches the ground, and still going over 5 miles an hour. So those legs feel a fair amount of crush. We still don't know the state of the vehicle right now. We need to look to make sure there are no rocks nearby. The solar panels will be in just a few, in about 5 to 10 minutes. Will begin to open up. They're waiting for the dust to settle, because the dust there's certainly a lot of dust being lifted in the air around the vehicle right now, which is now just settling.
So we're standing by after touchdown. It waits a couple of minutes to give us an X-band beep. And so we are standing by for that. It's a communication that comes directly to Earth from InSight.
Yes. And it goes to the Deep Space Network. There's also something that might be happening now, if we're very lucky. InSight might be able to relay an image or a partial image taken just a couple minutes after landing. So I'm standing by hoping to see that. But if that doesn't happen, we'll certainly get more images later in our Odyssey pass in about 5 hours.
We see Bruce Banner waiting for it.
Yeah, they're
I don't know if they see it yet.
They're waiting. That's Justin Mackey and Bruce Banner looking carefully at the cameras to see what they might see. They're waiting for the image to come back.
So this is the first image from InSight itself. InSight is taking a picture with one of its 2 cameras.
Yes.
It's probably a view of what's directly in front of the spacecraft, right in front of the lander. This is a camera that it would be using to figure out, is this a good space?
Exactly.
Is it a good place to put down our instruments? So it is going to take an image and then send that image to the Marcos. The Marcos in turn will relay it back down to Earth.
That's correct. They got it. Oh,
Let's see.
now let's just wait. Let's see what they saw. There it is. Wow, right. It's a great place. That's a good thing. That's not far from where we'll be able to deploy the instruments. So it's great. I don't see a lot of.
Let's explain that image. Now, this image has a dust cover on top of it.
EDLCom, we have lost the signal for Marco.
You can see potentially a lot of.
Radio science
a lot of debris
reports
that might be on the camera.
LS for UHF.
So we don't know what I'm looking at.
Thank you, everybody on EDLCom.
All right.
Yeah. Yay, Marco. Congratulations.
Meantime,
Oh, there it is. You can see a better view. You can see that really is debris. And there's the horizon back there, the bluish sky. That's part of the lander deck on the front left. I can't make out, but it looks like there's not a lot of rocks in the field of view. But those dots you see there are very likely to be dust particles on the lens, the dust cover, which will be removed.
and we'll get another shot
Yes.
later on.
Yes.
Pretty
and a better,
amazing.
clearer view after the dust cover is removed. So Insight's, CubeSat's relay communications job is done. They're now flying on. They're now taking pictures back toward Mars. Hopefully, MRO, which flew overhead, might have been lucky enough to capture the descent of this InSight lander under its parachute. While this was going on, MRO was flying overhead, recording the data, also monitoring the transactions and recording every bit of signal it could. But it also had the ability to take a picture, and maybe like we did with both Phoenix and later for Curiosity rover, we might be able to see the parachute inflated as well.
That would be fantastic. We are standing by now for that X-band beep.
Yes.
InSight phoning home saying, I'm here and I'm okay.
Systems Ace on Insight Cord, the DSN and X-band.
Radio science reports X-band carrier detected.
DSN and X-band radio science have acquired the X-band touchdown signal for Insight. X-band will continue for 4.5 minutes with Insight in nominal mode.
Copy that. Thank you.
Flawless. Flawless.
We've got the beep. This was perfect case scenario.
This
in my book.
is what we really hoped and imagined in our mind's eye. Though we spend most of our visualizing all these bad things can happen.
That's true.
Sometimes things work out in your favor, and we'll look very carefully at the data to see what might have, how well it went. But it certainly looked like it was a very successful and perfect landing. We'll have to see as we get more data how well things go. And as the vehicle proceeds, the solar panels will be deployed. Hopefully, we're not on a tilt. It doesn't look like we are, but from the image. But the solar panels will be deployed safely, we hope, and we'll get confirmation of that around 5 o'clock local time here in about 4.5 hours, 5 hours from now.
And this is such a difficult feat in that because of the one-way light time, there is no way that any of these engineers could possibly control the vehicle. It all has to be done in commands and software.
We have to train it to do this work on its own.
Radio science reports nominal carrier 30 seconds past the first acquisition. So we're all nominal on the surface.
So the vehicle is completely nominal, reported nominal. It's happy. The lander is not complaining. We had a way to tell us if it was unhappy, and it wasn't. It's not unhappy. It's in a normal mode.